Hey guys, today we're going to have a recap on electrical charge and current. First of all, let's recap on the equation we know that has current in it, which is V is equal to IR. This is the relationship between voltage, current and resistance. But what is current? I want you guys to pause the video and pick which definition you think suits current. Okay, hopefully you guys have chosen and that you've chosen that current is the rate of flow of charge. So the relationship between current and charge is that it's the rate of flow of charge. So therefore it's current multiplied by time, which is what's equal to Q, the charge. So over here you can see that charge has the symbol Q, and it's measured in this thing called coulombs. So it has a unit C. So here's just a quick recap on the symbol and unit. So for charge, our symbol is Q, and our unit is a coulomb. For current, our symbol is an I, and our unit is an ampere, so capital A. For time, our symbol is T, and it has a unit seconds. Resistance, our symbol is R, and it has a unit ohms. And voltage has a symbol V, capital V, and a unit capital V. So hopefully that recap has helped, because sometimes you get asked, give the unit. So if you were asked to give the unit of charge, you'd give a coulomb. Okay, so back to this thing, Ohm's law, V is equal to IR. What it's saying, if you're given a question where it's asking what happens to the current if the resistance is increased for a voltage that stays the same, you could think about it like this. So if you think about little circle electron things, and you have a resistance, say the resistance is the green bar. If your green bar is small, implying that if your resistance is small, you're gonna have quite a lot of current flowing through. But if your resistance is big, you're not gonna have a lot of current flowing through. So if the resistance is big, you have a smaller current, but if your resistance is small, you have a big current. Hopefully that makes sense. Okay. So I'm going to give you an example here on how to use Ohm's law. Well, I want you to pause the video and try it out for yourself first, and then we can go over it. So first of all, we've got a circuit here. It's in series. You have two resistors in series, X and Y, and you have a voltage of 18 volts. Now remember, in a series circuit, you're going to have voltage shared, but the current is the same throughout the resistors. So if I want to calculate the voltage across X, what am I going to do? Pause the video. Okay, hopefully you've unpaused the video now. So if I want to calculate the voltage across X, what I'm going to do is I'm going to use Ohm's law. And I'm going to say, if I know my resistance is 3 ohms across X, and I know my current is the same throughout the whole circuit, so it's 2 amps, I'm going to have 3 multiplied by 2, using this equation here, to get 6 volts across X. Remember, voltage is shared, so voltage here and here will be different. Okay, pause the video and try and calculate the voltage across Y. Okay, hopefully you've unpaused the video now. So to calculate the voltage across Y, what you're going to do is you're going to remember that voltage is shared. And we know that the voltage across X is 6 volts. So essentially it's just 18 minus 6 to give you 12. So the voltage across Y is 12, because the voltage of the resistors has to add up to the total voltage. So hopefully that makes sense. If not, let me know. But well done to those who got it. Okay, now we're going to use this equation here, Q is equal to IT, in a way that hopefully makes sense. So this is going to be a simple question. It's a typical exam style question. So if you have a light bulb and it has a current of 1.7 and it's working at 30 minutes, I want you guys to pause the video and try and work out what the charge is. Okay, hopefully you guys have unpaused the video now. Now to work out the charge using this equation here, what we're going to do is essentially multiply this and this. But remember, time has unit seconds, and this is in unit minutes. So what you want to do is you want to convert minutes to seconds. So 30 times 60 gives you 1,800 seconds. So that's what your T is. If you multiply that by 1.7, you get 3,060 coulombs. For those who got it right, well done. But just remember the tricky thing about this question is the minutes part. So if you do minutes, if you see minutes, always convert it to seconds. Okay, hopefully that makes sense. Thank you for watching the video. See you later, guys. Bye.